R1 dash is equal to R1 plus R2 plus R3, or C1 dash is also equal to C1 plus C2 plus C3. 1, 1, 1, A, B, C, A square, B square and C square. What is to prove? A minus B, B minus C and C minus A. If A square minus B square means A plus B into A minus B. For B square minus A square, B plus A into B minus A. Minus B square minus AB minus A square. Cancel. Plus A square minus A square gets cancelled. C square minus B square, one term. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, the faculty of mathematics, Vidhyaashram PU College, the Temple of Excellency. Now in the previous classes, I have discussed regarding the properties of determinants and few problems based on the properties of determinants. In this session, I am going to discuss regarding the problems based on properties of determinants. Now let us take the first problem. What is the problem given? Prove that A minus B, B minus C, C minus A, B minus C, C minus A, A minus B, C minus A, A minus B, B minus C is equal to 0. What is to prove? The value of the determinant is equal to 0. Now as I told in the previous classes itself, while solving this type of problems such a way that it should reduce us to some of the 7 properties. So to get the answer as 0, let us convert in such a way that all the elements in a row or column are zeros, or any 2 rows or 2 columns are zeros. So here you can easily convert all the elements in any row or column as zeros. Now let us take LHS. What is LHS? LHS, A minus B, B minus C, C minus A, again B minus C, C minus A minus B, C minus A minus B and B minus C. So this is the LHS. What is to prove here? This is equal to 0. Now listen, very simple. This is row 1, row 2, row 3, R1, R2, R3. If you add, see if you add A minus B plus B minus C plus C minus A, minus B plus B gets cancelled, minus C plus C gets cancelled, plus A minus A gets cancelled, 0. Similarly, add this B minus C plus C minus A plus A minus B, minus C plus C gets cancelled, minus A plus A gets cancelled, minus B plus gets cancelled, 0. Again add this C minus A plus A minus B plus B minus C. So minus A plus A gets cancelled, minus B plus B, minus C plus C gets cancelled. All the elements are found to be 0, 0, 0. Then easily it will reduce us to your answer. So that can be written as taking, you can take R1 dash is equal to R1 plus R2 plus R3. You can choose you can write R1 dash is equal to R1 plus R2 plus R3, or C1 dash is also equal to C1 plus C2 plus C3. Anything you can choose this. Now here this can be written as, I'll write row 2. I am taking R1. So row 2 is same, B minus C, C minus A and A minus B. Row 3, C minus A minus B and B minus C. So row 2 and row 3 are same. Row 1 I am going to add first element of row 1 plus first element of row 2 plus first element of row 3. That is A minus B plus B minus C plus C minus A. Add this A minus B plus B minus C plus C minus A. Again add this B minus C plus C minus A plus A minus B. Now for this, add these elements C minus A plus A minus B plus B minus C. Now what happens? So this is equal to, see here, so minus B plus B gets cancelled, minus C plus C gets cancelled, minus A plus gets cancelled, 0. So you will get 0 in the 0 as the first element. This is same, B minus C and C minus A. Next, here also minus C plus C, minus A plus A, minus B plus B gets cancelled, 0, 0 and C minus A minus B. C minus A minus B. Here minus A plus A minus B plus B gets cancelled, 0, then A minus B, B minus C. This is what you are going to get after conversion of R1 dash is equal to R1 plus R2 plus R3. Now observe carefully. Here what happens in the first row, all the elements are 0. If all the elements in a row or column are zeros, then the value of a determinant is equal to 0. So this is equal to 0 because all the elements in first row are zeros. So that is the reason. So all the elements in first row are zeros. The value of a determinant is equal to 0. That's your RHS. That's all. So I will explain once again. Let us take LHS. LHS, A minus B, B minus C, C minus A, B minus C, C minus A, A minus B, C minus A, A minus B, B minus C. Taking R1 dash is equal to R1 plus R2 plus R3. R2 and R3 are same. Second row, B minus C, C minus A, A minus B. Third row, C minus A, A minus B, B minus C as it is. Add this. A minus B plus B minus C plus C minus A. First element of row 1, first element of row 2, first element of row 3. First element of R1 is A minus B. First element of row 2 is B minus C. First element of row 3 is C minus A. Similarly, second element of R1, R2, R3. Second elements are these. B minus C, C minus A plus A minus B. Similarly, third element C minus A plus A minus B plus B minus C. Everything gets cancelled. In the first row, all elements are equal to 0, 0, 0, 0. So, B minus C, C minus A, A minus B, C minus A, A minus B, B minus C. Second row and third row are same. In first row, all the elements are zeros. If all the elements are zeros in a row or column, then the value of a determinant is equal to 0 according to the property. So, therefore, the value of this determinant is equal to 0. That is to be proved. That is your RHS. Hope you understood this. Now, coming to the next problem, the problem number 2, second problem, what is to prove? Prove that first column 1, 1, 1, A, B, C, A square, B square, C square is equal to, what is the answer? A minus B, B minus C and C minus A. This is very important problem for the point of examination. So many times this question is repeated. So you may get this type of problem. So you may expect this question for your final examination. 1, 1, 1, A, B, C, A square, B square and C square. What is to prove? A minus B, B minus C and C minus A. Now let us take LHS. 1, 1, 1, A, B, C, A square, B square and C square. Now let us simplify this, taking R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R1. Let us take R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R1. So that is, first column is same, first row 1 A square as it is. So this is, now R2 minus R1, this minus this, R2 minus R1, this minus this, 1 minus 1 is 0, B minus A and B square minus A square. Next, R3 minus R1, this minus this, third row minus first, 1 minus 1, 0, this is C minus A and C square minus A square. Followed? So, very simple. First here, so 1 A square as it is, row number 1 is same. Change R2 dash is equal to R2 minus R1. Second row minus first row, 1 minus 1, 0, B minus A, B square minus C square. Similarly, R3 dash is equal to R3 minus R1, 1 minus 1, 0, C minus A or C square minus A square. Now, see here, what happens? These two elements are 0. So, what is the intention? Convert this C minus A as 0 according to the definition of a property. If all the elements below the principal diagonal are zeros, then this is equal to product of principal diagonal elements. You will get the answer. Now, convert this as 0. Before that, if at all any common factor is there, you can remove the common factor. Let me take this can also be written as 1, 0, 0. Now, you know the formula for A square minus B square. A square minus B square is nothing but A plus B into A minus B. So, here this A as it is, B minus A is also same, C minus A as it is. Now, A square into this B square minus A square is of the form A square minus B square. If A square minus B square means A plus B into A minus B. For B square minus A square, B plus A into B minus A. For c square minus a square, c plus a into c minus a. So, b square minus this can be written as b plus a into b minus a. And again, c square minus a square can be written as c plus a into c minus a. Right. Now, you can remove the common factor. So, what is the common factor here? I can take b minus a as common factor and c minus a is also the common factor. So, I can take b minus a and c minus a as the common factor. Now, listen. So, let me explain this. Taking r2 dash is equal to r2 minus r1, r3 dash is equal to r3 minus r1. 1a square as it is, 1 minus 1 0, b minus a, b square minus a square, 1 minus 1 0, c minus a and c square minus a square, 1a square as it is. Here 1, this is 0, b minus a, b square minus a square can be written as b plus a into b minus a, and c square minus a square can be written as c plus a into c minus a. Now, just remove b minus a and c minus a as common factor. This b minus a and c minus a is a common factor. Then what you are going to get in the first column 1 0 0. I will go to the next page. 1 0 0, a b minus a c minus a, b minus a c minus a, and a square b plus a into b minus a, c plus a into c minus a. This is from that page. Now, what is the common factor? B minus a is the common factor here. B minus a, again c minus a is the common factor. So, 1 0 0, this is a, b minus a is gone 1 and this is 1, b minus a is, this is a square, what is remaining is b plus a into c plus a. Now, so just convert this element as 0, convert this element as 0. For that, you are going to take r3 dash is equal to r3 minus r2, r3 minus r2, enough, r3 minus r2. R3 minus R2, this minus this. So, that is equal to B minus A into C minus A into, this is 1A square, 0, 1, B plus A, and subtract this. 0 minus 0, it is 0. 1 minus 1 is 0. Again, what is there here? C plus A minus B plus A. C plus A minus B plus A. C plus A multiply by negative sign, minus B, minus into plus, it is minus A. Minus A plus A gets cancelled. You will get C minus B. So, here it is C minus B. Okay. Now, this A, yes, you know this B minus A can also be written as minus of A minus B. Multiplied. Now, B minus A can also be written as minus of A minus B. So, therefore, B minus A can be written as minus of A minus B into this C minus A as it is. And according to the definition, all the elements below the principal diagonal are 0. So, therefore, the value of this determinant is 1 into C minus B. So, this is minus of A minus B into C minus A into C minus B. So, this is minus of A minus B into C minus A into C minus B can also be written as C minus B can also be written as minus B plus C, or you can remove minus common factor, minus of B minus C, minus of B minus C. Now, this minus and minus becomes plus, put it in order, A minus B, B minus C and C minus A. So, the answer is A minus B, B minus C into C minus A. This is the required answer. That's your RHS. That's all. That's it. Very simple. So, see here from the previous page. So, you can remove B minus A common factor and C minus A common factor 1 0 0, A 1 1, B minus A, C minus A is gone, B plus A into C plus A. Convert this one as 0. For this, subtract R2 dash is R3 dash is equal to R3 minus R2. So, B minus A, C minus A as it is, 0 minus 0, 1 minus 1 is 0, C plus A minus B minus A, C plus A minus B plus A is multiply by negative sign, minus B minus A plus A gets cancelled, C minus B. So, you will get 1A square, 0 1 B plus A, 0 0 C minus A. C minus B. So according to the property, if all the elements below the principal diagonal are 0, then it is equal to product of principal diagonal elements. So therefore, this is 1 into 1 into C minus B, C minus B, interchanging. So B minus A can also be written as minus of A minus B, and C minus B can also be written as minus of B minus C, minus into minus plus, A minus B, B minus C, C minus A, put it in order, A minus B, B minus C and C minus A is the required answer. That is our result. Very simple. Just convert all the elements below the principal diagonal or above the principal diagonal as zeros and multiply it and interchange. If what is required, then you will get the answer A minus B, B minus C and C minus C. That's all. Hope you understood this. Okay. Now let us come to the next problem. The next problem is similar to that of the previous problem. So here 1, 1, 1, A, B, C, A cube, B cube, C cube is given. Instead of A square, B square, C square, here we have A cube, B cube, C cube, and we are making use of the formula A cube minus B cube formula. That's it. Now let us take LHS. What is LHS? So LHS 1, 1, 1, A, B, C, A cube, B cube, C cube. Now instead of taking R1 and R2, R3, let us taking C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C1. Let us take column 2 is C2 minus C1 and column 3 dash can be written as C3 minus C1. Let us take the columns. Now this is equal to, first column is same. First column is this column 1 A cube as it is, C2 minus C1, subtract these two, 1 minus 1 0, B minus A and B cube minus A cube. Next C3 minus C1, this minus this, 1 minus 1 is 0, again C minus A and C cube minus A cube. Okay. Now see here, these two, so convert this element as 0 and simplify, you will get the answer. So taking LHS 1, 1, 1, A, B, C, A cube, B cube, C cube, taking C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C1. So this is 1 A cube as it is, 1 minus 1 0, B minus A, B cube minus A cube, 1 minus 1 0, C minus A and C cube minus A cube. So observe carefully, this is of the form A cube minus B cube. So you know the formula for A cube minus B cube, just make use of A cube minus B cube formula and simplify, you will get the answer. So there is a formula for A cube minus B cube. What is A cube minus B cube? A cube minus B cube can also be written as A minus B into A square plus AB plus B square. A cube minus B cube is equal to A minus B into A square plus AB plus B square. So this can be written as, this is equal to 1 0 A cube as it is, and this is 0 B minus A, and this B cube minus A cube can be written as B minus A into B square plus AB plus A square, that is A square plus B, AB plus B square. And similarly this is 0 and C minus A, this can be written as C minus A into C square plus CA plus A square. This is the determinant. 1 0 0 0 B minus A, C minus A cube, B minus A into B square plus AB plus A square, C minus A into C square plus CA plus A square. Now here, so I can remove B minus A common factor. Here we can remove C minus A common factor. So 1 0 A cube, 0 1, this is gone, B square plus AB plus A square you will get 0, C minus A is gone, you will get 1, this is C square plus CA plus A square. Let me go to the next page. So this is equal to, I can take the common factor. So here 1 0 A cube, B minus A and C minus A is the common factor. B minus A into C minus A is the common factor. What is this? 1 0 A cube, 1 0 A cube, and the next line 0 1 B square plus AB plus A square, B square plus AB plus A square, 0 1 and C square, 0 1 C square plus AC plus A square. This is the step from the previous. Now what is the intention? See, This is the principal diagonal element. Convert this one as 0. If you convert this one as 0, you will get the answer for that. Again, taking C3 dash is equal to C3 minus C2. Subtract these two. So, what you will get? B minus A into C minus A. This is 1, 0, A cube, and this is same 0, 1, B square plus AB plus A square. Now 0 as it is, this is 0, 1 minus 1 it is 0. Again subtract this. See here, C square, these two, C square plus AC plus A square minus, multiply by negative sign, minus B square minus AB minus A square. Now cancel the terms which gets cancelled. So anything gets cancelled? No, nothing will get cancelled. Equate the square terms. So it will get cancelled, plus A square minus A square gets cancelled, and what is remaining is C square minus B square. C square minus B square plus AC minus AB, make it as one group. This is nothing but C square minus B square is nothing but C plus B into C minus B, plus here A is the common factor, C minus B. Again in this, C minus B is the common factor, C minus B is out. What is remaining? C plus B plus A. This can be written as C minus B into A plus B plus C. So this can be written as C minus B into A plus B plus C. Okay. Now see, all the elements above the principal diagonal are 0. Therefore this is equal to, the answer is B minus A into C minus A into 1 into C minus B, that is C minus B into A plus B plus C. So put it in order. So this can be written as minus of A minus B, minus of into minus of B minus C into C minus A into A plus B plus C. So this is equal to minus into minus plus. The answer is A minus B into B minus C into C minus A into A plus B plus C. This is the RHS. Very easy problem. Hope you understood. Listen, I will explain once again from this step. So taking C3 dash is equal to C3 minus C2. So 1 0 0 A cube, this is as it is. 0 minus 0 is 0, 1 minus 1 is 0, C square plus AC minus A square. Subtract these two, that's all. Subtract these two. C square plus AC plus A square minus B square plus AB plus A square can be written as, multiply by negative sign, minus A square minus AB minus B square minus AB minus A square. Cancel, plus A square minus A square gets cancelled. C square minus B square one term, and group it as one. AC minus AB as other group. So this is A square minus B square again. C square minus B square can be written as C plus B into C minus B. Again here common factor is A. If you remove A common factor, C minus B. In these two, what is the common factor? C minus B. So you can remove C minus B common factor. C plus B plus A is left over. So put it in order. C minus B into A plus B plus C. Substitute here. So this is C minus B into A plus B plus C. Since all the elements above the principal diagonal are zeros, therefore the answer is equal to 1 into this term, that is 1 into anything is C minus B into A plus B plus C. So put it in order. B minus A can also be written as minus of A minus B, C minus as it is. C minus B can also be written as minus of B minus C into A plus B plus C as it is. So therefore it is minus into minus plus, A minus B, B minus C, C minus A into A plus B plus C is the required answer. That is the answer. Okay. So if it is A square minus B square, use A square minus B square formula. A cube minus B cube, use A cube minus B cube formula, that is A minus B into A square plus AB plus B square. That's what regarding this problem is concerned. Come to the next problem. Next problem. What is the problem? Same. Prove that minus A square AB AC BA minus B square BC CA CB minus C square is equal to 4 times A square B square and C square. This is very simple problem. Just observe carefully. So here this contains A common factor, here B common factor, here C common factor. Or if you observe like this, A is the same, B is same, C. So you can take A, B, C common factor out from R1, R2, R3 or C1, C2, C3. Now let us taking out, take LHS, I'll write the LHS minus A square BA CA AB minus B square CB AC BC minus C square. Now taking A, B, C out from, so here you can take A, here B, here C from R1, R2 and R3. So listen, this is A, B, C. So first take A from the row 1. So from row 1 I can take A minus A is gone, B, A is gone, C. Similarly take B from row 2. So A, 1B is gone and C. Similarly I can take C from R3. If I take out, this is A, take C out, B and 1C minus C you will get. Okay, so what you will get? A, B, B, B and C, C, C. Again you can take A, B, C out from C1, C2, C3. So again taking A, B, C out from C1, C2 and C3. Column 1, column 2 and column. First column, second column and third column. So if I take A, B, C out, what I am going to get? So listen, taking A, B, C out from R1, R2, R3. So row 1, you can remove A minus A, B, C. Here you can remove B in the row 2, A minus B, C and C common factor A, B and minus C. Again taking A, B, C out from C1, C2 and C3. So I will go to the next page. So A, B, C, this is equal to A, B, C into, we are taking A, B, C out. What is left? So here minus 1, 1, 1, minus 1, 1, 1, again 1, minus 1, 1, 1, minus 1, 1, again 1, 1, minus 1, 1, 1, minus 1. So by taking A, B, C out from R1, R2, R3, C1, C2, C3, you are going to get this much. Multiply this. A into A is A square, B into B is B square, C into C is C square. Expand this, plus, minus and plus. So minus 1 into 1 ones are 1, minus 1, minus 1 into this row and column is deleted, minus 1, plus 1 into this row and column is deleted, 1 into 1 is 1, minus into minus is plus 1. So this is equal to A square, B square, C square. This is 0, minus 1 into minus 2, plus 1 into 2. So this is A square, B square, C square, minus into minus plus, 1 2s are 2, plus 2. So this is equal to A square, B square, C square into 2 plus 2 is equal to 4. So this can be written as 4 times A square, B square, C square. So therefore the answer is 4 times A square, B square, C square. That is the required RHS. Very simple problem. So just take A, B, C out from R1, R2, R3, C1, C2, C3. It will reduce us to minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. So left hand here you are going to get A square, B square, C square. Expand this determinant. This is equal to 2. 1 plus 1 is equal to 4. 2 plus 2 is equal to 4. A square plus B square plus C. A square, B square, C square into 2 plus 2 is 4. That is 4 times A square, B square, C square is the required answer. That is the required answer. Hope you understood this. Now come to the next problem. The next problem is, this is also an important problem. What is the problem here? A minus B, A minus B minus C, 2A, 2A, 2B, B minus C, C minus A, 2B, 2C, 2C, C minus A minus B is equal to A plus B plus C whole the cube. So let us take LHS. What is LHS? A minus B minus C, 2B and 2C, 2A, B minus C minus A, 2C, 2A, 2B, C minus A minus B. This is LHS. Now let us take, see here, if I add this, a minus b plus c plus 2b plus 2c, what you will get? 2b minus b is 1b, 2c minus c is 1c. So a plus b plus c will get. Here also 2a plus b minus c minus a plus 2c. So 2a minus a is 1a, you will get. B already 2c minus. So here also 2a minus a is 1a, 2b minus b is 1b. So therefore you can take r1 dash is equal to r1 plus r2 plus r3. Now taking r1 dash is equal to r1 plus r2 plus r3. So that is row number 1, this is R1, R2, R3. Now let us change R1, I will keep R2 as it is, that is 2B, B minus C minus A and 2B. This is 2C, 2C and C minus A minus B. Add this R1 plus R2 plus R3. So that is A minus B plus C plus 2B plus 2C. Similarly, 2A plus B minus C minus A plus 2C. Similarly, this 2A plus 2B plus C minus A minus B. What is this equal to? This is equal to, see here, A, yes, A as it is, 2B minus B is 1B, 2C minus C is 1C. A plus B plus C, this is 2B, 2C as it is. Here 2A minus A is 1A plus B, 2C minus C is 1C. So A plus B plus C, this is same, B minus C minus A, 2C. B minus C minus A and 2C. Now 2A minus A is 1A, 2B minus B is 1B plus C. So this is also A plus B plus C into 2B into C minus A minus B. Now, so observe carefully, first row contains, this row contains A plus B, A plus B, A plus B. So you can remove the common factor. A plus B plus C is the common factor. It reduces to 1, 1, 1 and simplify. That's it. So listen. So taking R1 dash is equal to R1 plus R2 plus R3. Row 2, row 3 are same. A minus B plus C plus 2B plus 2C. 2A plus B minus C minus A plus 2C. 2A plus this, 2B plus C minus A. So you will get A plus B plus C, A plus B plus C, A plus B plus C. This is same. So I'll go to the next page. So you can remove A plus B plus C common factor. You will get first row as 1, 1, 1. So here A plus B plus C common factor. So we will get 1, 1, 1 here. 2B, B minus C minus A, 2B. 2B, B minus C minus A, 2B and 2C, 2C, C minus A minus B. So 2C, 2C, C minus A minus B. This is you are going to get. Now A plus B plus C common factor 1, 1, 1, 1. Now what you will do? Change this, that's all. Taking again C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C1. So A plus B plus C into column 1 is same. 1, 2B, 2C. Subtract these two. So 1 minus 1, 0. See here B minus C. B minus C minus A minus 2B. So what you will get? Minus A. B minus, this is minus B minus A. You can remove minus A plus B plus C. So this becomes minus of A plus B plus C and 2C minus 2C 0. Again come to this, these two. R3 minus C3 minus this. 1 minus 1, 0. 2B minus 2B minus 2B 0. Again this is C minus A minus B minus 2C. So minus A minus B minus 2C plus C is minus C. You can remove minus out A plus B plus C. So this is again minus of A plus B plus C. That's it. See, all the elements above the principal diagonal are zeros. These are zeros. Then this is equal to A plus B plus C, A plus B plus C into 1 into minus of A plus B plus C into minus of A plus B plus C. What is this equal to? A plus B plus C minus into minus plus A plus B plus C into A plus B plus C is A plus B plus C whole square. This is totally equal to a plus b plus c whole the cube, that is your required RHS. That's it. That is the answer. Very simple. Hope you understood. So listen, a plus b plus c common factor from the first previous step. So 1 1 1 in the first row, 2b b minus c c minus a, 2c c minus a as it is. Now convert these elements as 0, all these three elements as 0. For this subtract these two, c2 dash is equal to c2 minus c1, 1 2b 2c as it is, c2 dash is c2 minus c1, 1 minus 1 is 0, b minus c minus a minus 2b can be written as minus a minus 2b and minus c minus common factor a plus b plus c, and 2c minus 2c is 0. Again c3 dash is equal to c3 minus c1. So 1 minus 1 0, 2b minus 2b 0, c minus a minus b minus 2c, c minus, yes, c minus a minus b minus 2c can be written as, so that is nothing but c minus a minus b minus 2c minus a minus b minus 2c plus c is minus c, this is c. So that is, you can remove minus out, a plus b plus c. Substitute here, minus a plus b plus c. So since all the elements above the principal diagonal are zeros, therefore the value of determinant is equal to 1 into minus of a plus b plus c into minus of a plus b plus c. So 1 into minus of a plus b plus c into 1 into minus of a plus b plus c, minus into minus plus, a plus b plus c into a plus b plus c is a plus b plus c whole square. A plus b plus c whole square into a plus b plus c is a plus b plus c whole the cube. That's all. Very simple. So practice, that's it. If you practice, these are all constant problems. The steps are same. It won't changes. R1 dash is equal to R1 plus R2 plus R3. C2 dash is equal to C2 minus C3. C2 dash is equal to C2 minus C1. C3 dash is equal to C3 minus C1. So that's it. Simplify. It will reduce us to some properties and evaluate it. That's it. Okay. Hope you are following. Now let us come to the next problem. What is the problem? Prove that x plus 4 2x 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 x plus 4 2x 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 x plus 4 is equal to 5x plus 4 into 4 minus x whole the square. Let us take LHS x plus 4 2x 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 x plus 4 2x 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 and x plus 4. Now let us see here. So if you add x plus 4 plus 2x plus 2x, so 2x plus 2x is 4x plus 1 is 5x plus 4. The first part of the answer you are going to get. So you can add this or that. Even if you add this x plus 4 plus 2x, you will get 5x plus 4. So therefore taking R1 dash is equal to R1 plus R2 plus R3. So row R2 is same. R2 is 2x into x plus 4, 2x as it is. R3 2x into x plus 4. This is same. Adding, first add R1 plus R2 plus R3. First element of R1, first element of R2, first element of R3. X plus 4 plus 2x plus 2x is x plus 4 plus 2x plus 2x. I will write here x plus 4 plus 2x plus 2x, 2x plus 2x, 4x plus 1x is 5x plus 4 you will get. So this can be written as 5x plus 4. Here also 2x plus x plus 4 plus 2x, 2 plus 2, 4 plus 1 is 5x plus 4. So this is also 5x plus 4. Even if you add 2x plus 2x, 4x plus 1 is 5x plus 4. That is the first row. So in the first row, 5x plus 4 is the common factor. I can take 5x plus 4 as the common factor. So listen, I will explain once again. Taking R1 dash is equal to R1 plus R2 plus R3. So second row is same 2x, x plus 4, 2x. Third row is same 2x, x plus 4. Add this x plus 4 plus 2x plus 2x. X plus 4 plus 2x plus 2x is 5x plus 4. Again 2x plus x plus 4 plus 2x. 2x plus x plus 4 plus 2x is 2x plus 2x. 4x plus 1 is 5x plus 4. So same 2x plus 2x is 4x plus 1x is 5x plus 4. So I can take this as a common factor. So take this as a common factor. I will go to the next page. 5x plus 4 is the common factor. 5x plus 4 common factor in the first 1, 1, 1. Whereas come to the second 2x x plus 4, 2x x plus 4, again 2x x plus 4, 2x x plus 4. So from the previous page, 5x plus 4 common factor 1 1 1, 2x x plus 4 2x, 2x and x plus 4. Now same here also you can take C2 dash is equal to taking C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C1. So 5x plus 4 as it is. Column 1 is same 1, 2, 2x same. Subtract this to C2 minus C1, 1 minus 1 is 0. See here x plus 4 minus 2x is x, yes 4 minus 2x plus x is x. So you will get 4 minus x, 2x minus 2x is 0. Again these two, C3 minus C1, 1 minus 1, 0, 2x minus 2x is 0, x plus 4 minus 2x. So this is nothing but 4, yes this is 2x. So yeah, 4 minus 2x plus x is minus x. So you will get 4 minus x here. Now this is equal to, so 5x plus 4 out as it is, and see all the elements above the principal diagonal are zeros. Therefore this is equal to product of principal diagonal elements. So this is equal to 1 into 4 minus x into 4 minus x, 4 minus x into 4 minus x. This is 5x plus 4 into 4 minus x into 4 minus x is 4 minus x whole square into 1 is 4 minus x whole the square. So the total answer is 5x plus 4 into 4 minus x whole square, which is the required RHS. That's your answer. Followed? Hope you understood. So 5x plus 4 is a common factor from the previous step. 1 1 1 in the first row, second row 2x x plus 4 2x, third row 2x and x plus 4. Subtract this one first column as it is, C2 minus C1, C3 minus C1. So 1 minus 1 0, x plus 4 minus 2x is 4 minus x, 2x minus 2x is 0, 1 minus 1 is 0, 2x minus 2x is 0, x plus 4 minus 2x is 4 minus x, that I have written there. So see, if you observe carefully, all the elements above the principal diagonal are 0. Therefore this is equal to product of principal diagonal elements. So that is equal to 1 into 4 minus x into 4 minus x is 1 into 4 minus x whole square. 4 minus x square into 1 is 4 minus x whole the square. So therefore that is equal to 5x plus 4 into 4 minus x whole square, which is the required answer. So these are all the problems based on the properties of determinant. So you may get either the expansion, the proof for one property, or the problem based on this proof. You are going to get it for 3 marks. Very simple. Practice, practice, practice. Particular problem, the steps are same. So you just practice. Definitely it seems to be easy for you. So that's all for the day. We will meet in the next class. Thank you.